So this is the topic that we were talking about last time, radioactivity. And radioactivity is the process of emission, like to emit out radioactive radiations from the nucleus of an atom, right? And we also discussed that all the elements beyond lead in the periodic table are radioactive, and we don't need to remember their name, right? It is important to know that you don't need to learn the name of the elements. You don't need any periodic table in your exam. All the questions, all the name of the elements are given by the examiner in your paper. Okay. So not like chemistry, we don't require any periodic table. We don't need to learn names, right? We just need to know that radioactivity is random and spontaneous process. Random means there is no pattern. It can be occur at any time in any pattern. Okay, so there is no specific pattern of it. Second thing is spontaneous. Spontaneous means on radioactivity process there is no effect of any external factor. Like if you increase temperature of outside, so there will be no effect on radioactivity. If you change pressure, there will be no effect on radioactivity. And if you change other factors in your atmosphere, in your surrounding, so there will be no effect of all other factors on radioactivity. So this is the concept. Then we discussed there are three types of radioactivity: alpha particle or alpha rays, beta rays or beta particles, gamma rays, right? And we also discussed that if there are so many elements, those are radioactive. So it depends upon their nature that a single element can emit one type of radiation, or it can also emit two type of radiation, or it is also possible to emit three types of radiation from single nucleus or from single element. Okay. Now, this is the main thing that we have to discuss. Last time we discussed about their nature only. In nature, we only discussed that alpha radiation or alpha particle are exactly the copy of helium nucleus. So alpha looks like the helium nucleus, right? This time, uh, you can see there are two protons and two neutron in helium nucleus. So in the same way, alpha particle also consists of two proton and two neutron. And as we know that this is radioactive element, and radioactive element means to emit something, right? So for example, if we have any specific nucleus, so from that specific nucleus in a single time, alpha particle emits two proton and two neutron, right? In the same way, if we consider beta, so beta are fast moving electron. Fast moving electron means, electrons are negatively charged particles. So it means it only emit one electron at single time. Okay. If there is beta radioactivity. And if we consider gamma, so for gamma, you can see these are high frequency electromagnetic radiation. So there will be no number of proton, no number of neutron emit from gamma. There will be only frequency or electromagnetic radiations coming out from the nucleus. So these are the nature of alpha, beta, and gamma. The second point is to represent their symbol, right? So, yes, any question?
Sorry, can you explain the property of alpha again?
Basically, alpha is a material, you can say, or it is a particle in which we have two protons and two neutron. So in simple words, we can say, let's suppose if we have a football, right? So that football is the nucleus, right? So from that nucleus, uh, the size of alpha particle is equals to 2 proton and 2 neutron. Let's suppose alpha is the size of tennis ball, is equals to the size of tennis ball. So from the football, you can like emit out the size of tennis ball out of that. So it means in the same way, if we consider that football as a nucleus, so from that nucleus, the size of alpha particle is equals to 2 proton and 2 neutron. So you need to take out 2 proton and 2 neutron from that nucleus. So that is alpha particle. Okay. We will discuss examples also. There are examples in our
Okay,
equations.
sir.
Yes. So then it will be easy with the help of the numbers. Right now, you just need to keep in our mind that when they talk about alpha, so alpha means 2 proton, 2 neutron. So it means we need to subtract 2 proton and 2 neutron from the nucleus. Okay. If they talk about alpha, if they talk about beta, so it means only 1 electron. And if they talk about gamma, so it means no proton, no neutron. So this is the concept of nature, right? And the symbol of alpha, you can see this is the symbol of alpha. You can write like this or this. This is two number of proton and this is the number of nucleons, just like the helium. Okay. So it's up to you how you can write the symbol of alpha. In the same way, this is the symbol of beta. So you can write like this, or with the help of the number of electron, you can also represent in another way. But for gamma, you know, there is no proton, no neutron. So there is only one representation for gamma. So these are the symbols for alpha,
Sir,
beta, and gamma. Yes.
what is EM? You've written in the gamma as nature.
Okay, basically that is for gamma, and EM means electromagnetic radiations.
Okay.
Electromagnetic. Electromagnetic means combination of electric field and magnetic field. Light is the example of electromagnetic field, right? Radio waves, radio signals, satellite signals, these all are the example of electromagnetic radiations, right? Or electromagnetic waves. And you know that all these like radio waves, microwaves, or satellite waves, these all waves are invisible, right? We are not able to see by our normal eye because they have their different frequency, different wavelength. So in the same way, the gamma has its own property, just like the electromagnetic radiations. Okay, the next thing is charge. So in alpha, we know that there are two proton. Two proton means plus two charge, right? Because proton have positive charge. So if you have two protons, so your charge will be plus two, right? In beta, we have one electron. One electron means one negative charge, minus one, okay? And in gamma, there is no proton, no electron, so it means zero, right? No charge. So this is the concept of the charges between alpha, beta, and gamma. Okay. And the next thing is penetration, right? For example, if uh you strike alpha on something, so maybe it will pass through that material or maybe it will block from that material, right? Penetration means when you fix a thumb pin into the soft board, so that is called penetration, like to pass through something or pass into another material. When you observe any bullet hits any object, so definitely that bullet penetrates into the object or into the material because bullet can easily pass through many materials, right? So in the same way, if we consider their penetration power, like how long they can pass through any material. So if we talk about alpha, so we know that alpha is heavy because there are two protons, two neutrons. So alpha is heavy as compared to beta and gamma. Okay. So that's why you can see the penetration of alpha is least in the sense as compared to beta and gamma. And description is also given. Due to large size, it can be stopped by a piece of paper, right? So for example, if you have a simple piece of paper and you strike alpha on it, just like if you remember Rutherford experiment. In Rutherford experiment, we consider gold foil, right? That's why we consider gold foil over there, because gold foil is more thin as compared to the paper, right? You know, aluminium foil, if you take aluminium foil and paper, so aluminium foil is thin as compared to the paper. So in the same way, gold foil is also thin as compared to the paper. So alpha particle or alpha radiations are not able to pass through the paper. It can be stopped by the paper. Okay. So let's suppose if you know that alpha radiation is coming out from any nucleus, so you can wrap that material into the paper so radiation can easily be stopped, right? Any confusion? Okay. If you consider tissue paper, you know tissue paper is also very thin as compared to normal paper. So alpha particle can pass through tissue paper, but not from the normal paper. Okay. So this is called penetration. Like alpha can easily pass through tissue paper, like it can pass through the tissue paper on the other side, but it cannot be able to pass through the simple papers. And if we talk about beta, so beta is small in size as compared to alpha. And you can also compare with the example of the dart game. So you know that the dart is very pointed. So dart can easily penetrate into the board, right? So in the same way, if you consider very small mass, so that a small mass can easily penetrate through any object. But if you consider very heavy mass, so it will be difficult to like penetrate heavy mass into the object. Okay. So according to this scenario, we can see uh beta is able to more penetrate than alpha due to smaller size. And if you want to stop beta particles, so beta particles can be stopped by 1 centimeter to 2 centimeter thick aluminium sheet,
Yes,
right?
sir.
Yes. Yes.
Also, I thought you were saying something like asking us something. Your
No,
voice
no.
was lagging a bit. Now it's fine.
Okay. Okay, so basically for beta, we know that beta is less in mass as compared to alpha. So it can easily penetrate through paper also. Beta cannot be stopped by the paper. Beta can easily pass through the paper. And if you want to stop beta, so you need few thickness like about 1 or 2 centimeter thick aluminium sheet to stop beta, right? So in question, if they ask, so you know that you have to write few centimeter of aluminium sheet or few centimeter thickness of aluminium sheet can easily stop beta particle. Okay. And if we compare gamma, so there is no mass of gamma according to the nature of gamma. It is only electromagnetic radiation. So definitely electromagnetic radiations can easily pass through many materials. And to stop electromagnetic radiations, for example, if you consider Wi-Fi signals, right? So if you are in a room, your door is locked and there your windows is closed, so still you can receive signal of your Wi-Fi that is placed on in another room, right? So that is the example of penetration, right? They can easily penetrate through the walls and through different materials. Okay. You are still getting signals. In the same way, electromagnetic radiations, gamma, are also electromagnetic radiations. So it can also penetrate through different materials like aluminium, paper, or other material also. But if you want to stop gamma radiation, so for gamma radiations, you required a thick lead block of few centimeter thickness. You can see. Okay, these numbers are just for your reference, right? You don't need to learn exact number. Okay, it is not compulsory. These are just for your reference. So it can be stopped by, you can write it's stopped by few centimeter of lead or concrete. Okay. So this is the property of penetration for alpha, beta, and gamma. Any question? Okay. And the next thing is about their range. Okay. And you can see alpha can travel through few centimeter, around 4 to 5. Okay. They will not ask about exact number. Again, you can see this is just for your reference. They will not ask about exact number. If we talk about beta, so beta can travel few meters, like 1 to 2 meter. Okay, not very long distance, but few meters. And if we talk about gamma, so gamma can easily travel several meters. Okay, so this is the range of alpha, beta, and gamma. And if we talk about their speeds, so you can see the speed of alpha is around 10 to the power 6, like 1,000,000 in this way, meter per second. And if we talk about beta, so beta is less than the speed of light. You know this value 3 into 10 to the power 8. This is speed of light. So beta is almost close to the speed of light, and gamma can easily travel with speed of light. Okay. So these are the speeds of alpha, beta, and gamma. And in your exam, you will not like asked by the question about the speed. Okay. This is also just for the reference. In your question, you will not given like questions to write down the speed, but this will help you to compare their speeds very easily. They are almost close to each other, not very far away from each other. They are close to each other. And the last important thing is about ionization. Last time you remember we discussed a question related to ions. If electron is like gained by any atom, so it becomes negatively charged or negative ion. And if electron is loosed by any nucleus or atom, so that becomes positively charged. So if we talk about the ionization process, so ionization process is simple in alpha. Why? Because alpha is greater in size, so it will be very easy for us to ionize alpha particle. Okay, because it is large in size as compared to beta and gamma, and it will be very easy for us to uh, make ionization process possible in alpha. And if we talk about beta, so beta is small in size as compared to alpha. So that's why it will be difficult to ionize. So less ionization than alpha due to less charge. And finally, gamma. So there is no charge on gamma. So it will be very difficult to perform ionization process. So that's why the ionization of alpha is least, ionization of gamma is least as compared to alpha and beta. Okay. So these are the properties when we
Okay.
solve questions. So it will be like revision again and again. So when we revise the concept again, so you will got exact idea that what is going on. And this is
Sir,
hmm,
in the range, what does it mean? Like, what is it referring to by the range word?
it means
Range,
how long
range of.
travel. Let's suppose if all of them started from zero, so alpha can only travel around 4 to 5 centimeter, then it will vanish. Okay, this is the range maximum
For what? The atom moving range or
radiation.
the
Yeah.
subatom?
No,
Okay,
the moving range
radiation.
of
Okay.
radiations, right? Like alpha radiation, beta, and gamma. Because radiations are coming out from the nucleus. So when they come out from the nucleus, so after that, alpha can travel few centimeter, beta can travel few meters, and gamma can travel through several meters, right? So this
Then
is the range.
speed is referring to the range and speed of the uh,
Yes, speed refers to the moving speed of alpha, beta, and gamma. Like how fast alpha can move, how fast beta can move, how fast gamma can move, right?
okay, sir, got it.
Okay. And just one more thing related to their properties. You can see we have magnetic field concept and electric field concept. So first of all, if we talk about electric field, because electric field is easy to understand. In electric field, you can see we know beta is negatively charged, alpha is positively charged. And you know that opposite charge attract each other, right? Just like magnet. In magnet, north attracts south and north repel north. Okay. So same charge repel each other, unlike charge attract each other. So that's why you can see alpha bend towards the negative plate, right? This is negative charge plate. So alpha is positive, so alpha attracts towards the negative one. Okay. And if we talk about beta, so beta is negative. So beta attracts towards the positive one. Okay. And there is one difference if you feel that alpha travels at long distance, then it bends. But beta bends at short distance, right? So what is the reason? Reason is very simple because alpha is heavy. So it takes time to bend alpha particle or alpha radiation, right? And beta is lighter as compared to alpha, so it will be easy to bend the direction of beta. So alpha is heavy, so it takes time to bend, right? That's why you can see alpha bends at long distance, but beta is light as compared to alpha. It is light as compared to alpha, so it bends with greater angle. Okay, right? Any confusion?
No, sir.
Sir, can you explain why the
Hmm.
it like bends at a greater angle, but the other one takes
Okay,
time to bend?
okay. Let's suppose if you consider the example of a heavy truck, right? And then you compare it with cycle, right? Let's suppose if you want to take a U-turn, right? You are taking U-turn with the help of cycle, and in parallel, there is heavy truck that is going to take U-turn. So you know that truck takes more time because it is long and it is very heavy, right? So that truck takes U-turns very slowly, right? But you are on a cycle, and cycle is a small in size as compared to truck, and it is also short. So it can easily take U-turn very quickly, right? So in the same way, beta is like the example of that cycle because beta is very light, very small, so it bends very quickly. Okay, because it is light in weight and light in mass as compared to alpha. But alpha is like that heavy truck. It is like greater in mass. It is large in size also as compared to beta. So it takes time to deflect alpha from its original position. Okay, so this is the concept.
Okay, sir, now I understand.
And gamma is neutral. So gamma moves always in a straight line. There is no change in direction for gamma. Okay. So you can see.
Sir, can gamma rays radiation is
Hmm.
can it like pass through the things? For example, if it is done in a nuclear bomb or something, so it will have its according to its radiation speed,
Yes. You can
it
see.
will move that much.
Yes. You can
Okay.
take reference from point number 4. You can see the penetration power. So it can easily penetrate. It can easily pass through many objects. It is like X-rays, right? X-ray can easily pass through your body, but it cannot pass through your bones, right? So gamma is more
Yes,
strong than X-ray, so it can easily pass through your bone also, right? So
that's
this
why
is
beta is used.
no, it is dangerous to use because it can damage your bones also. X-rays are harmful, but we know we don't have any other alternate, right, to find out fracture. So that's why we are using X-ray. But X-rays are not very harmful or not such harmful as compared to gamma. But let's suppose if you directly expose gamma particles on your body. So if you remember the example or the incident of the atom bomb on Hiroshima, right? So it takes so many years to come out from the after effects of atom bomb, right? Because
Yes,
radiation are going to be add in your atmosphere, and they can stay there for very long time, right? And you will get this idea in the topic of half life, right? So the next topic is half-life, and in that topic, you will get to know that how these radiations can stay for very long time in the atmosphere. So that's why atom bomb is very dangerous because the explosion of atom bomb is not dangerous, right? But the after effect, the radiations coming out from that is very dangerous because it will retain in atmosphere in that specific area for very long time, even for many years. So all the bodies, all the human bodies, all the nature can easily affect by those radiations because it is going to be last for very long time in that specific region where we have that atomic explosion or atomic bomb explosion. So that's why gamma is very harmful, very dangerous as compared to X-rays, right?
so sir, alpha particles are used for the in X-ray or beta.
Basically, X-rays are also electromagnetic, right? So they are
Right. So
also
sir,
in the
which
category.
particles are used?
Basically, there are no particles because in alpha electromagnetic radiation, there are only high frequencies. So there are no particles, there are only
Okay.
high frequencies that can pass through your body, just like Wi-Fi signals, right? We cannot see those Wi-Fi signals, but still they can pass through different objects, right?
Okay, sir, got it.
So
Thank you.
those are just like wireless signals. Gamma rays are also like wireless signals. So they can easily pass through and it can easily damage and affect our bodies. And after electric field, if we talk about magnetic field, so for magnetic field, we need to like study about electromagnetism chapter. But right now, you can remember the deflection of alpha and beta because alpha and beta have opposite charge. So that's why they have opposite deflection, right? So in this, you can see that they both deflect in opposite direction, just like in electric field. Again, alpha is heavy, so it takes more time to deflect. Beta is lighter, so it takes less time to deflect. Okay. So this is the concept of magnetic field also. Like if we want to discuss in detail that why alpha bends in this direction, why beta bends in this direction, so we need to know about electromagnetism concept, right? But that is the part of electricity chapter. So just for the time being, you can just consider like this, that both deflects in opposite direction, right? Alpha deflects in upward direction and beta in downward direction, because you always get question like this. Okay. When we talk about electricity chapter, so then I will explain you that why alpha and beta, or why positive negative deflects like this. Okay. They will not ask in detail in nuclear physics chapter, they will ask detail in electricity chapter, right? Because this is the part of electricity, electromagnetism. Okay. Any question, any confusion?
No, sir.
No, sir.
Okay.
No, sir.
So these are the properties of alpha, beta, and gamma. And these properties are very important for your exam questions, because we are going to get so many questions from their properties, right? So after properties, let's try some question.